Hello, children. You would have faced problems like prove that root 2, the square root of 2 is irrational. And you would have come across these methods of proving by contradiction. Now, the purpose of my video is to explain to you what is proof by contradiction. You would be using this proof by contradiction in different mathematical situations. Now, I have a student also along with me so that I want you to understand what I want to teach today. The student will represent all of you because I can't see all of you, and he would question me in between if he doesn't understand. So I hope you would be able to understand whatever we are going to do today. So now let us take this known fact that natural numbers are not finite. All of us know this, it's intuitive that natural numbers are not finite. But how do we prove that they are not finite? So let us adopt this proof by contradiction. Now, what is this basically? Consider a crime, a crime investigation. There are some suspects. The police are suspecting four people. They feel that they might have committed the crime, but there is only one of them who has actually committed the crime. But what do they do? What is their procedure? They'll have to interrogate each and everyone. They have to interrogate any random person and find out whether he has committed the crime. And they will question him. And if the questions seem to be contradicting their assumption that he has committed the crime, then he would be proved to be innocent. So suppose they question one, and then during the process of questioning, they find out that this person was not in the place where the crime was committed, that he was maybe in a foreign country. So they would have assumed that he has committed the crime, but since he was in a foreign country, now that they can prove, they can conclude that this person is innocent. Now again, they will go to the second person and start questioning him. So I hope my student here also understands what I'm
Okay,
trying.
so this is interesting because no matter if I choose this person number to say,
Okay,
it's more likely that he hasn't committed the crime,
it is
right?
more likely,
Yeah,
yes.
but still they assume that he has,
Yeah,
and
because that is their only way of proving that the
yeah,
crime has not been
right,
committed
right,
by him.
okay,
Okay. So now, so whatever their assumptions, if the assumptions are contradicted by the questions they ask and by the answers they get from this person, once their assumptions are contradicted, they conclude that this person is not guilty. So we are going to use this same scenario, this thing in our proof of natural numbers are not finite. So how are we going to start? Can you guess? How are we going to start?
uh,
What do we assume here? Our assumption would be
so I'm
the
supposed to,
opposite.
yeah, so
Uh,
okay, so I'll assume that they are in fact finite, maybe.
yeah, yeah,
Yeah.
yes, their assumption is natural numbers. Natural numbers are finite. So now we have to see what can be done to prove that this is wrong or this is absurd. This is absurd, right?
Okay.
So let us say that natural numbers are a limited, collection,
Okay.
and they can be written in this 1, 2, 3, so on, and some x, some y, and say some n.
Okay.
Now let us arrange this collection in ascending order for our convenience. So between x and y, so any random number you pick up, say x and y, either x is less than y or x is greater than y. So in cases of x is equal to y, we wouldn't take such cases, we would only take one of them in this collection.
Okay. Why so?
We will have all distinct elements in this collection of finite sets.
Okay.
We will not have repetitive
So
elements.
we assumed that already.
We assume that.
Okay.
So let us arrange this in ascending order now. So our arrangement would be something like this: 1, 2, 3, and maybe 10,000 is present in this set, and so on, and let n be the largest number in this collection of finite collection of natural numbers.
So ma'am, you're proposing that if I think of any natural number, it will be already in the set, or
it should be
Yeah,
already
yeah,
in the set, and the largest of them would be n. But
right? Okay.
can there be a natural number? Say n is also a natural number. This 1 is also a natural number. So n plus 1 has to be a natural number. Will that be contained in this set which we have taken? Will n plus 1 be present in this set?
Yeah, it should. Yeah, it should be, right?
It should be, but it will not be, because we have assumed that n is the
Oh, because
largest.
you have ordered the number.
We have
already.
ordered in the ascending order.
Okay.
So n is the largest among them. So n plus 1 would not be there. Similarly, n plus 2 is a natural number. N plus 2 will not be there in this set. So what does this conclude? This goes against our assumption, isn't it?
Right.
It goes against our assumption. So we'll have to conclude that
Our assumption is wrong.
our assumption is wrong and natural numbers are not finite. So we have a proof, because the whole thing contradicts our assumption. This whole thing contradicts our assumption. So we have a proof for natural numbers are not finite. So this is all. The purpose of this video was proof by contradiction, to explain you what is proof by contradiction, and I hope you understood that through this video. Thank you.